Good morning, everyone. So today let me discuss about relative stability analysis. Okay. So first let us look at what is relative stability analysis, and once we understand relative stability analysis, we'll be able to solve more problems on RH criteria related to relative stability analysis. All right. Now, this relative stability analysis is normally applicable to a stable system. Okay. For an unstable system, we will not carry out the relative stability analysis. Only for a stable system, this relative uh, stability analysis is carried out. Okay. To understand the relative stability analysis, let us consider two systems. Let's say system 1 and system 2. Okay. And let us say that um, C of S, that is C of S by R of S, is something like, let's say for example, some k divided by uh, S plus 2. And in system 2 you have C of S by R of S is equal to k divided by S plus 10. Okay, S plus 10. Now, as you can see from both the system description, that both are stable systems in the sense, if you consider, let's say for example, impulse response, you will get C of t as some constant k into e to the power minus 2t. And similarly, here you will get the impulse response C of t as k into e to the power minus 10t. So when time t tends to infinity, so this exponential function decays to 0. Similarly, as time t tends to infinity, again this exponential function, some e function, um, decays to 0. So both are stable systems. Now, the question under consideration is, out of these two systems, which is better? All right, both are stable systems. Out of these two systems, which system is better? So that is nothing but your relative stability. So relative stability is carried out for a stable system. If you have more than one system, we will try to judge the goodness of the system in terms of relative stability analysis. Okay, so let's see how exactly we will try to say a particular system is better than the other system. Okay, so for both the systems, let us draw the pole zero plot. So pole zero plot is nothing but the location of poles and zeros in a complex S plane, right? So first let's draw the pole zero plot of system 1. Okay, so what do you have? You have a zero, sorry, pole, right, which is located at minus 2. So when you equate S plus 2 to 0, you will get the location of this particular root, which is at minus 2. Similarly, when you equate S plus 10 to 0, you will get the root value as minus 10. So let's say minus 10 is somewhere over here. Alright. Both are stable systems because their roots are found in LHS of the S plane. Okay, so this is your LHS. LHS. Okay. So this is sigma and this is j omega. Sigma and j omega. Minus j omega. Minus sigma. Okay. Now, Both are stable systems. So relative stability is basically judged on the basis of settling time. The system which settles, faster is said to be relatively more stable uh, than the other system. Okay. Now, how would you determine the settling time? So settling time, we have seen that it's given as 4 by zeta omega n for plus or minus 2% of tolerance, right? So 4 by zeta omega n. Now, what is this zeta omega n? So this zeta omega n is nothing but real part of root or pole of the closed loop transfer function. So zeta omega n is nothing but real part of root or poles of the closed loop transfer function. Okay. So you can find settling time for system 1 as well as system 2. So for system 2, let's say TS2, and for system 1, let us say TS1. So TS1 is equal to 4 by zeta omega n. So zeta omega n is a real part of the pole. So what is the value here? It is minus 2. Obviously, when you take out the settling time, you would consider the modulus. So 4 by 2, that is 2 seconds. Alright. On the other hand, if you calculate TS2, how much you will get? 4 by zeta omega n, right? Mod zeta omega n, and the value is 10. So 4 by 10. So basically, TS2 is equal to 0.4 seconds. So system 1 gives 2 seconds of settling time, and system 2 gives 0.4 seconds of settling time. So system 2 is taking lesser time to settle down or lesser time to find its steady state value. On the other hand, system 1 takes longer time to settle down. So on this basis, you can say that system 2 is better or relatively more stable compared to system 1 because system 2 takes lesser time to settle down. So this is all about the relative stability analysis. All right. Thank you.